In this video, we'll create an MCP server for the Hedera Mirror Node APIs. Then we'll interact with Hedera via that MCP server via an agent implemented in LangChain and LangGraph. Previously, we have started from scratch and built agent.js, which is a blockchain AI agent with very minimal functionality. If you have yet to, go watch that video from the beginning of the playlist. Links will be provided in the description. Hi all, I'm Brendan and welcome to Hands-on DevRel. Hedera Mirror Node APIs are defined using OpenAPI. So what is OpenAPI? This used to be known as Swagger, but now it's renamed. It is a standard API specification format using either YAML or JSON for HTTP APIs. It is essentially a programmatic description of the API exposed by a server. It uses a standardized format. This page is a graphical user interface rendering that is based on the OpenAPI definition in YAML, and it is also interactive. So this is useful for developers because you can use it as a reference documentation to explore and learn about a particular API. Also, you can try out the APIs very easily without needing to write any custom code first, so you can just do that up front. For example, if I wanted to look up a Hedera account using its account ID or EVM address, I can use this API. Another example, let's explore HCS topics. If I wanted to get all of the messages for a particular HCS topic by ID, I can use this API. That API that we just looked at, it corresponds to this section in the YAML file. Essentially, developers do not need to write their own code to interact with OpenAPI if they don't want to. Instead, they can simply use off-the-shelf libraries or frameworks or user interfaces that are designed to support the OpenAPI specification. That is the power of the standardization. And this is also precisely what we are going to do. We are going to create an MCP server by simply taking this OpenAPI YAML specification and putting that into a library called OpenAPI MCP Server. This library will essentially act as a proxy translator, converting between standard HTTP requests and the MCP server format. And we're not done yet. Our AI agent is built on LangGrapHJs, and that does not know how to talk to an MCP server. It does, however, know how to talk to LangChain tools, which is what we've been using in the previous versions of the agent. So we need to convert between those two formats. To do so, we'll use this library called LangChain MCP tools to do this purpose, for this purpose. So just to recap, we have OpenAPI specification to MCP server, and then MCP server to LangChain tools. So that's the sequence that we're doing. All right, let's begin. So first off, we'll create a file named mcpagent.ts. Note that the libraries that we'll be using for this one do not work in JavaScript, so we'll have to use TypeScript. I'll be running this using Bun, but feel free to use any alternative TypeScript runtime that you like. Let's give this file executable permissions and use Hashscan at the top to indicate that it should be run using Bun. Now, let's install LangChain MCP tools. Let's also install OpenAPI MCP server. Next, copy the entire OpenAPI YAML file. This is the specification for the entire Hedera Mirror Node APIs. Then create a file within the project directory and paste the full contents into it. In this file, there needs to be just one small change, which is the URL of the first value of the server's configuration. Let's get the server URL for the Hedera testnet Mirror Node API from the OpenAPI interactive docs. Back in the YAML file, paste that URL in. Copy the MCP server config from the README of the LangChain MCP tools library. Then, we'll update it to run OpenAPI MCP server and point it at the YAML file for the Hedera Mirror Node APIs that we have just edited. Copy the line to initialize tools from the README as well. Name this variable MCP LangChain tools. Once we have this, we put the tools into an array and then construct a tool node from it. After this, the process is pretty much the same as setting up the agent that we've done previously using createReactAgent. Next, we need a chat interface. For this, we'll simply copy-paste it over from the agent that we have created previously. Now we're ready to run the agent. Run the script with the command mcpagent.ts. From the output, we can see that using these libraries, we have 44 LangChain tools available, and each of these tools correspond to one API of the Hedera mirror node. Updating the config to name the MCP server Hedera mirror node and then rerunning the script. Let's chat with the agent to get it to query the Hedera testnet mirror node API. We'll ask it to retrieve data from this HCS topic that we've been writing jokes to using previous versions of the agent. The prompt is, please get message with sequence number 11 from HCS topic ID 00 something. The idea is that the LLM should parse this and inspect the LangChain tools that have been bound to it and work out that it should invoke a particular mirror node API. Looks like there was an error and the fix is simple. Simply need to remove the /API/v1 string that was at the end of the server URL. Now let's rerun the script and prompt the agent with the same prompt as before. We get a response from the agent with all the details. Now this is interesting because we have an AI element in it, and this is where we get something different than, say, a simple wrapper around an API. You can see in the agent's response, the message appears to be encoded in base 64. Would you like me to decode it for you? So let's try doing this query manually using the OpenAPI interactive docs. Find the appropriate section from the API, which is this one for topics, and then look at the one with the URL path parameters for both topic ID and sequence number. Press the Try It Out button. Input the topic ID and the sequence number into the form fields and then press the Execute button. In the server response, we see the output. This has done essentially the same thing as what the AI agent has just done as well. And we're doing this to check the accuracy of the agent. Let's repeat the prompt, but this time let's give it something more complex. First, we tell it to retrieve multiple messages from the same topic by specifying 2 sequence numbers. Secondly, we tell it that we're only interested in the message field and that it should be base 64 decoded before being displayed. Let's check that the agent has indeed retrieved the appropriate messages from the HCS topic. And it looks like it has indeed done just that. Alright, we're done. See you in the next video where we will make an AI agent that adds human in the loop, which is where the agent needs to ask you, the human being, chatting with it, for permission before performing certain actions. Subscribe to get notified when it comes out.